Right now, on the far edges of this planet, there is a wind that can freeze exposed skin in under a minute. Not metaphorically, physically. In seconds, the water inside living tissue begins to turn to ice. It is dark for months at a time. The sea itself is capped in solid rock-hard ice, and the temperature can crash past minus 60 degrees Celsius. Nothing warm-blooded should be able to stand in that. And yet in the middle of the coldest, blackest night on Earth, there is a colony of birds standing shoulder to shoulder, holding a single egg on their feet, breeding in the worst weather the world can throw at anything. While you turn up the heating and reach for another blanket, an entire cast of animals is out there in the freezer, solving a problem that should kill them, using tricks so strange and so precise that they feel almost like cheating physics. This is the story of how animals survive the coldest places on Earth. And by the end, you will understand the single hard limit that even the toughest of them is now being pushed past, faster than at almost any point in their history. Let's start where the cold is heaviest, the poles, and with the animal everyone pictures on the ice. An animal almost everything you assume about is wrong. The polar bear. It looks white. It is not. Under that famous coat, the polar bear's skin is black, the better to soak up what little sunlight reaches the Arctic. And the fur itself is not white either. Each hair is hollow and clear, a tiny transparent tube that scatters light so the whole animal looks the color of snow, while it actually lets warmth through to that dark skin below. Beneath all of it sits a layer of blubber up to 11 centimeters thick. Blubber is not just fat for burning as fuel. It is a fitted, waterproof survival suit, wrapping the animal in a dead-air jacket that water cannot strip away, which matters enormously because a polar bear spends much of its life in near-freezing sea. The result is an animal so well insulated that it barely shows up on a heat-seeking camera. It leaks almost no warmth into the freezing air at all. And here is the strange part. A polar bear's bigger problem out on the pack ice is not staying warm. It is overheating when it runs. The insulation is so good that a hard chase after a seal can leave the bear dangerously hot, and it has to stop, spread out on the ice, and dump the excess heat through the few bare patches on its nose and the pads of its feet. In one of the coldest places on Earth, the deadliest risk for its top predator can be getting too hot. Now shrink the scale. Trotting across the same ice on tiny feet is a creature that looks like it was designed by a heating engineer. The Arctic fox. It survives temperatures down around minus 50 without even beginning to shiver. Look closely and you'll see the whole body is built to hoard warmth. The ears are small and rounded, the muzzle short, the legs stubby. Every shape chosen to keep as little surface as possible exposed to the wind. Even the soles of its feet are covered in dense fur, which is where its scientific name, meaning hare-footed, comes from. It walks on insulation. Its winter coat is the best of any mammal on the planet, so effective that the fox stays comfortable long after most animals would have frozen. And on the treeless Arctic plains stands a shaggy survivor that carries the warmest coat nature has ever grown, the musk ox. From the outside, it looks like a walking haystack, a wall of long dark guard hair hanging almost to the ground, but the real magic is hidden underneath. Against the skin grows a layer of fine wool called kivyot, and gram for gram it is warmer than sheep's wool and warmer than almost anything humans have ever spun. It is so effective that a musk ox can stand calmly through a full Arctic blizzard, snow piling on its back without melting because so little body heat escapes to melt it. When the wind screams, the herd simply turns its armored heads outward, packs the young into the center, and waits the storm out like a living fortress. Good insulation solves half the problem. But there is a deeper trick, one you cannot see at all, and nearly every cold-blooded survivor shares it. Think about a penguin standing barefoot on the ice, or a seal with bare flippers pressed against frozen water. Why don't those thin, exposed parts simply freeze solid? The answer is a piece of plumbing so elegant it is used again and again across the animal kingdom. It is called countercurrent heat exchange. The warm blood heading down into the foot runs right alongside the cold blood coming back up, and the arteries and veins are bundled so tightly together that heat jumps across from one stream to the other before it can be lost. Warm blood is cooled on the way down, so it barely wastes any heat into the ice. Cold blood is rewarmed on the way up, so the animal's core never takes the shock. The feet are kept just above freezing, cold enough not to melt the ice they stand on, warm enough never to turn to ice themselves. It is why an emperor penguin can stand on Antarctic ice for months without frostbite, and why a seal can swim in water that is literally below zero. The Weddell seal takes this further than almost anything alive. It lives farther south than any other mammal, spending much of the polar winter not on the ice but under it, in the black water below, where it is sheltered from the killing wind above. To breathe, it scrapes and saws breathing holes in the ice with its own teeth, keeping them open all winter long, then dives into the dark to hunt, insulated by blubber and warmed by that same countercurrent plumbing in every flipper. Its cousin the crab-eater seal hauls out in vast numbers on the drifting pack ice, and despite the name it never eats a single crab. It filters tiny shrimp-like krill from the freezing water through teeth shaped like an intricate sieve, growing fat and warm on the smallest food in the coldest sea. But now go under that ice completely, into the black polar depths, and you meet the strangest solution of all. Because down there the water can sit at minus 1.9 degrees Celsius, colder than fresh water can ever get, kept liquid only by its salt. Any normal fish dropped into it would freeze from the inside as ice crystals formed in its blood. So the fish of the Antarctic did something no other animals had to. They invented their own antifreeze. Their bodies are full of special antifreeze proteins that lock onto tiny ice crystals the instant they start to form and stop them from growing. The same idea we now copy to keep ice cream smooth and to protect transplant organs. One of them, the Antarctic ice fish, went even further. Its blood is not red. It is clear, almost colorless. Alone among all the animals with backbones, it has given up hemoglobin, the molecule that carries oxygen and makes blood red. Because in water this cold, oxygen dissolves so easily that the fish can absorb enough straight through its skin and its watery blood pumped by an oversized heart. A fish with see-through blood and built-in antifreeze, cruising calmly through water that would kill almost anything else. Deeper still swims the Antarctic toothfish, a large, slow, long-lived predator that patrols water sitting permanently below the freezing point of fresh water. It should be riddled with ice. It never is. Its whole body is laced with the same antifreeze proteins, produced in such quantity that they guard every drop of fluid, from its blood to its gut, keeping ice from ever taking hold. It even tunes its own buoyancy so precisely that it can hang almost weightless in the black cold, drifting for years in a sea that would freeze the life out of any ordinary fish. Insulation, plumbing, antifreeze, but the cold does something else cruel. It takes away the sun for months, and it takes away the food. So how do you survive a night that lasts an entire winter? For the emperor penguin, the answer is the most extraordinary act of teamwork in the natural world. As the Antarctic winter closes in and the temperature falls toward minus 60, with wind gusts that can top 200 kilometers an hour, the males gather in their thousands. Each one balances a single precious egg on its feet, tucked under a warm fold of belly, and then they do the only thing that can save them. They huddle. Thousands of birds pressed together into one dense mass, so tightly packed there can be 10 birds crammed into a single square meter. Inside that huddle, surrounded by all those bodies, the temperature can climb above freezing even as the storm outside tries to kill them. And here is the part that stops you cold. The huddle is not still, it moves. In tiny, shuffling steps, the whole colony slowly rotates so that the birds freezing on the windward edge are gradually carried into the warm center, and the warm birds take their turn on the outside. No leader organizes it. It emerges on its own, a living, turning furnace, sharing its heat so that everyone survives. The males do this for over 2 months in total darkness, eating nothing, having already fasted for weeks, losing nearly half their body weight, guarding a single egg through the worst winter on the planet, and waiting for the females to return from the sea with food. It is survival as a shared act. Alone, every one of them would die. Together, almost all of them live. Now leave the ice and climb, because the cold does not only live at the poles, it also lives in the sky. High in the mountains, the air thins, the temperature plunges, and the wind never stops. And yet even here, life has moved in. On the frozen cliffs of the Himalayas prowls the snow leopard, wrapped in the thickest, longest fur of any big cat. With a tail so long and dense it wraps around its own face like a scarf when it sleeps. Its paws are broad and furred underneath, natural snowshoes that spread its weight and grip the ice, and its huge lungs and nasal cavity warm the freezing thin air before it ever reaches those lungs. Sharing those same cliffs are the mountain goat and the Himalayan tahr, animals that graze on near vertical rock in weather that would ground a helicopter. The tahr grows a shaggy reddish mane and a dense woolly undercoat for the winter, and the mountain goat wears a double coat so warm it can bed down in an alpine blizzard and simply let the snow settle over it. All of them share the same quiet miracle, thriving on thin, frozen air on ledges where a single wrong step is fatal in a cold most animals would flee from. And some cold country animals refuse to fight the winter at all. They flee it. The Arctic tern, a small, slender seabird, breeds in the brief Arctic summer and then does something almost unbelievable. It flies away from the cold entirely all the way to Antarctica and back again, chasing endless daylight from one end of the planet to the other. Over its life, it can cover a distance equal to several trips to the moon and back, and it sees more sunlight than any other creature alive, simply by never staying anywhere long enough for the dark cold to catch it. Where the mountain goat digs in and endures, the tern votes with its wings. But insulation and huddling and altitude and migration all have their limits. So a few animals do something that sounds less like biology and more like science fiction. When the cold becomes truly impossible, they switch themselves off. Buried in the frozen ground of Alaska, the Arctic ground squirrel drops into the deepest hibernation known in any mammal. It lets the temperature of its own body fall below the freezing point of water, down to nearly -3 degrees Celsius, supercooling its blood so that it stays liquid even though it should be ice. Its heart slows to a beat every few seconds. Its brain activity nearly flatlines. For months it lies there, colder than ice, barely alive, and then in spring it warms itself back up and walks away as if nothing happened. But the ground squirrel keeps its blood liquid. One small animal does the truly unthinkable. It lets itself freeze. When winter comes to the northern forests, the wood frog does not burrow deep to escape the cold. It simply lets the cold take it. As ice creeps into its body, the frog floods its cells with sugar to protect them, and then up to 2/3 of the water in its body turns to solid ice. Its heart stops, its breathing stops, its brain goes silent. By every ordinary measure, the frog is dead, a small frozen statue among the leaves for weeks at a time, and then, when spring warms the forest floor, the ice melts. The heart shudders back to life, the frog thaws from the inside out, and it hops away to breed as though it had merely paused. And there is one creature that makes even the frozen frog look ordinary. The tardigrade, a microscopic animal barely visible to the eye, can be frozen almost to absolute zero, close to -270 degrees Celsius, and survive. When conditions turn deadly, it squeezes almost all the water out of its body and curls into a dried-out glassy grain called a ton. Its life all but stopped. In that state, it has endured being frozen for decades, boiled, dried to dust, blasted with radiation, and even the raw vacuum of open space. Add a single drop of water, and it swells, uncurls, and walks away, alive. What all three of these creatures share is a single, radical idea. When you cannot beat the cold, you can refuse to be present for it. The ground squirrel supercools, the frog freezes, the tardigrade dries to a grain, and each of them in its own way steps out of time until the world becomes livable again. So everywhere you look in the world's coldest places, life has found a door. Grow hollow hairs over black skin. Spin a wool warmer than any human cloth. Loop your warm blood past your cold blood so you never waste a degree. Fill your veins with antifreeze. huddle into a living furnace and share the heat, or simply freeze yourself solid, dry yourself to a grain and wait for the world to change its mind? Every one of these is a different answer to the same brutal question. How do you stay alive when the world is trying to freeze you where you stand? But here is the part that should make us all pause. Every one of these survival tricks was tuned over millions of years to a very specific kind of cold, an ancient, stable, dependable cold. And the poles are now the fastest changing places on the whole planet. The Arctic is heating up several times faster than the world as a whole. The sea ice that the polar bear hunts from, that the seal rests on, that the whole frozen web is built around, is thinning and vanishing earlier every year. And an animal perfectly engineered for deep cold has almost nowhere left to go when the cold retreats. A polar bear cannot simply move somewhere colder. The penguin cannot shrink its coat overnight. The wood frog and the ground squirrel are cued by the freeze and the thaw, and when those signals scramble, so does their entire year. The very perfection that let these animals conquer the ice is now a trap, because they are specialists in a habitat that is disappearing beneath them. And that is the quiet warning hidden inside all this wonder. These animals are not just astonishing, they are the front line. They live at the very edge of what life can endure, which means they feel the change before we do. The polar bear on the thinning ice, the penguin on the shifting shelf, the frog waking too early into a frost. They are the early warning system for a planet whose coldest corners are unraveling first. The ice has spent millions of years teaching its creatures how to survive the impossible. The real question now is whether that ancient cold will still be there long enough for those lessons to matter. So here is what we want to know from you. Of all these survivors, which adaptation amazed you the most? The penguins that build a living, turning furnace in the dark, the fish with clear antifreeze blood, or the frog that freezes solid, stops its own heart, and comes back to life in spring? Tell us in the comments. And if this changed the way you see the coldest places on Earth, stay with us, because the natural world is full of impossible things that turn out to be true.